Hello and welcome to another video. In this video we're going to be working on split linked list in parts. And in this one you're given the head of a strongly linked list and an integer k, and you're going to split the linked list into k consecutive linked list parts. The length of each part should be as equal as possible, and those two parts should have a size differing by more than one. This may lead to some parts being null. The parts should be in the order of occurrence in the list, and parts occurring earlier should have a size greater or equal to parts occurring later. Return array of the k parts. So in this first part, you want to have 5 parts. So basically, you're going to have 5 parts, and if you want to have the size as close as possible, the parts are going to be 0s and 1s. So they said to prioritize the first outputs to be bigger. So the first outputs will be 1s. So it'll be like length 1, length 1, length 1, length 0, length 0. And to do that, this is 1, 2, 3, and then these two are empty to be length 0. In example 2, k is 3. So you want to have parts that are either 3 or 4 elements. And so once again, you prioritize the first part to be bigger, so the first part will be this. Second part, third part. And there's 1,000 nodes. So the first part I want to talk about is like how to do this splitting between consecutive parts and making them as close to each other as possible. And this is kind of similar to a problem I did a few days ago, where essentially you have something of length x, right? And you want to split it into k parts. And so the way to do that is, let's just say we could split it evenly. That would be pretty easy, right? We could just do like x over k, and that would be the length of each item. So if we had like a length 9 item, and then k is 3, then we would just be like, okay, let's just make it everything size 3. But then there's the other thing that I talked about in the last video, which is called like the extra region. So you could figure out how much each part has to have. So like minimum value, or we call this the value, and that's just going to be x floor divided by k. So in this case, it'll be 3, for example 2. And then we have this like extra thing, which is how much extra stuff do we have. So when we do that, every item does have 3, but then we have 1 extra. So here, this is going to be x mod k. In this case, we have 1. And then it's pretty easy from there. All we have to do is just distribute this extra region into our output, and we can just check for every single like item in the array, do we have extra region left. So because we only have 1 extra region, whenever we put in the first element, we'll just say like we do have an extra, so let's add 1 more node there. And then when we go here, we won't have any extra, and we won't have any extra here. So that's kind of the idea, and that'll always make it distributed where everything is within 1 of each other, and it's like pretty easy to do. So essentially we can look at like one more example. Let's say x is like 35. And k is like 6 or something. So our length is 35, our k is 6. So our minimum value in every single node will be 35 floor divided by 6, which will be 5. And then the extra will be 35 mod 6, which will be 5. So essentially, basically what we're saying is the first 5 items will have 1 extra element, and every element will have 5 items. So we're going to split it into 6 different items, but the first 5 will have 1 extra item. So basically we can do 6, 6, 6, 6, 6, 5 would be the thing. Because all of these are added 1 because of the extra, and the rest one there is no extra region left over. So that's kind of the idea there to figure that out. So we can just go through the length of the array and like get the extra and figure out how long does every single region need to be. And then from there, it's basically just like, can you split that up correctly? And so the way I'm going to do it is I'll just draw this like an array, is I'll just have the dummy node like I talked about in previous videos as well. So I'll just have a dummy node point to the start of the linked list, so pretend this is a linked list. And then in this case, so we're going to split everything into chunks of 3, and then the first chunk will have 4, right, because out of the extra. So we're going to split this first chunk will have 4, and then 3 and 3. So how do we do this? Well, we're going to have a current node that will start at the head of the linked list, and then we're going to have a previous node that will start over here. And there's like a bunch of different ways to do this, but this is just one of them. And so at every iteration of the loop, we need to know what's the node right before the node that, like the chunk we're breaking off, right? Because in order to break off a chunk, what do you need to do? Well, you need to make a break here, and you also need to make a break before the chunk. So we're going to have one more pointer and that's just going to be initialized to wherever the previous value was at every iteration. And so what's going to happen here is we can just loop for the length of the chunk we want. So the first chunk is going to be length 4, right? Because it's going to be 433 with this extra thing. So basically all we're going to do in the loop is just move the current up. You honestly don't even need to, now that I'm thinking about it. No, actually, so it's going to be the same thing as the reverse linked list. We're just going to move the current and the previous up. So the current will end up going like 1, and then the previous will end up going 1. So kind of like this. This is like one iteration of the loop. Yeah. And then second iteration of the loop, third iteration of the loop, and then the last iteration of the loop. So our current is going to be like the node right after the chunk we want. And our previous will be the very end of the chunk we want. And now, like I said, we have this saved. This is going to get saved to wherever the previous was. So we can write that down, I guess, as a step. So set pointer to location of previous, and then loop prev and current up chunk length. Okay, so now what do we need to do? Well, we need to, like I said, we need to break off this thing. So we need to say that original pointer that we set in step 1. So pointer in step 1. We need to get its next, because that's what's going to get put in like the result, right? Dot next goes in result, and we make that pointer's next equal to null now, right? Because essentially what we want to do is we want to take this chunk, we want to put it in the result, we want to break this off. So I'm going to make that equal to null. And also what we need to do is we need to break this chunk right here. So we're going to say the previous next will also be equal to null. Actually, we don't necessarily need to do that. So we don't necessarily need to do that because we can put this whole chunk in the array and then we can break it up later. So what's going to happen is, like, I'll kind of walk through what will happen. So essentially what will happen is this whole thing will go into our result, right, in the first location. So basically this will get broken. This will move up here. So this is like the last step. Move up, or I guess this is step 1. So it's actually like this. Yeah. So basically what's going to happen is in step 1, this whole thing will get written into our result, into the first location. Then we need to repeat this thing again. So we're going to say set pointer to the location of previous, which is over here. Then loop in previous cur up trunk length. So the trunk length is 3, so we just loop these up 3. So, oops, let's move this. I'll just get rid of this, I guess, and just put it in later. So we move these up 1, 2, 3. And then that chunk that we put in was at the location of the old previous, which is right over here. So that's this. Okay. And then step 3. So the pointer goes in the result. So the next of this goes in the result. So basically what would happen is this goes in the result now. And then the last step is we make that pointer's next null. So basically what's going to happen is this pointer's next will be null. So 4 will no longer point to 5, it'll point to null. So because that's the case, this basically gets broken. And now this is the chunk we saved in the first part, but because 4 points to null, our first chunk will become this instead. And then we just do this again. So we set this equal to where the previous is. We move these up 3 times. So 1, 2, 3. This goes over here. And then same thing. We make this guy's next equal to null. So basically what that means is this will break. And we put this in the result. So 8, 9, 10 will go in the result of the next one. And because we make 7's next equal to null, so you can see how, like, even though we're putting in the whole linked list, it doesn't matter because we're not actually putting in the linked list, we're just putting in a node. And then we can make the node updates later. So because this is equal to null, it'll look like this. And now if you have any more regions, like let's say you did have more chunks where the current is out of bounds, basically you would just set the previous over here, this wouldn't loop at all because you have just empty chunks. And then this next goes into the result, which is just null. So you're just going to put nulls in the result. And then you make that pointer's next equal to null, but it's already null. So that'll handle cases like case 1, where these will be out of bounds after the first 3. Previous will be here, this will be here, and this will work. There's basically a bunch of ways to accomplish this, and just pick one that works. But the main thing is, like I said, figuring out how to make your chunks close to equal to each other, and that's the extra region. So hopefully that makes sense. If it's a little bit confusing, you can do this in a bunch of different ways. Like I said, it's basically just, can you manipulate linked lists, break them at the correct place. You can use more pointers if needed. If this is a little bit complicated, you can probably use less pointers. There's just a bunch of ways to do it. Okay, so that's what we're going to code. So we're going to make a result array. And then we're going to calculate the length of that array. So we'll just say this. And we'll say, so we'll just calculate the length of the array. The way to do that is just, you make the current equal to the head and say, well, current doesn't equal null. Let's just keep adding to the length and let's keep moving. So, because we need the length of the array to calculate the size of the chunks and the extra region. So we can call this like piece or chunk or something, which is length over k. In Java, this is a floor divide, so you don't need floor divide. Extra length mod k. And now, just like in this picture, we're going to make a dummy node, and we're going to set the previous equal to that. And we're going to set the cur equal to the head, because that's where we're starting. So now we just loop k times to get all of these chunks. So okay, and then let's just do this. And then basically what we're going to do is we're going to calculate how big the chunk is. So we can just say int j equals. So it's always going to be at least a piece, but then there might be one more if there's an extra. So we can just say like, so let's say there's like 5 extra pieces. So 0 to 4 will get the extra because we're prioritizing low indices. So we'll just say I is x less than extra 1, 0. Very similar to the other problem I did a few days ago. And then, like I said, we need a pointer to where we start that we're setting equal to the previous. This blue one. So we'll call this like before start or something. This will be the previous. Then while j is greater than 0, so essentially just for this chunk, previous equals cur equals cur next, j. Okay, so so we basically did all this. Now we have to say the pointer in step 1 next goes in result, and we make that pointer's next equal to null, which is this before start. So result I equals before start next. And before start x equals null. And yes, I think it should be it. So let's see. For these linked list problems also, if you get some stuff wrong, it helps a lot to just draw out this thing. So draw out like the linked list, draw out where all your pointers would be, go through your code, and then figure out like what you're doing wrong. It's gonna be super helpful at like visualizing, because it's really easy to get these pointers wrong. And there we go. Okay. And as I said before, for almost all these linked list problems, you're basically looking for a linear time and above 1 space. Don't make new nodes, just reuse the new nodes and split them correctly and stuff. And yeah, I think it's gonna be all for this one. So yeah, most of these linked list problems, I honestly think you don't need to do too many. It's just like, can you reverse it? Can you split it? Basically all you need. There's not too much stuff. There's not really like algorithms either. It's just like, can you make pointers and can you like move them correctly and make sure, use the right values and stuff. So it's just like not super difficult, I think. There's some of the easier problems. But yeah, that's going to be all for this one. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.